Yes. So this was the this was the question that suppose a system is there and there are forcing acting on it. There are forces and forces acting on it. Okay. Forces acting on it, and I'm saying the net force is not zero in first case. In the first case. And in the second case, the net force is equal to zero. Second case. So what do you think is going to be the momentum in this first case and in the second case?
Then the momentum in the first case won't be constant, but in the second case, the initial momentum is equal to final momentum. Momentum is constant.
Yes, because what is happening? The net force, although the forces are acting on it, in the first case forces are acting, but the force is not zero. Net force is not zero. That means there is some force acting on it. So if some force is acting on it, then momentum will change definitely. So here momentum will remain not constant. It will remain not constant. But what about this case? If I come to this case, what will happen? Here also forces are acting, but the net force is zero. If the net force is zero, the momentum will remain conserved. It's okay.
Yes, sir.
So this is the basic idea. We have written this: if the net external force on the system is zero, then the momentum will remain conserved. So I explain you this way also, that there may be a possibility that forces are acting on it. Then if the net force is zero, then momentum will remain conserved. And if the net force is not zero, then momentum will not remain conserved. It's okay.
Yes.
So now consider this example for n number of particles. If I consider this thing for n number of particles, what will happen? Shall I rub this part?
Yes, sir.
If I consider this system for n number of particles, what will happen? I will have to do the conservation of momentum for, let's say, n number of particles. In that case, what I will have to write? I will be writing like this: m1u1 plus m2u2. m1 is the mass of the first object, m2 is the mass of the second object, u1 is the initial velocity of first object, u2 is the initial velocity of second object. Likewise, m3 u3 up to number of particles, whatever the number of particles. Let's say we are having n number of particles, so we will be writing like this: mn un. And same over here, let's say m1 v1, mass remaining the same. I'm considering that mass is same. If the mass is changing, then we will write some m1 dash, m2 dash. If the mass is also changing, there is a possibility that mass may also change and velocity may also change. This is the example of variable mass system we have in rocket propulsion. When we study the rocket propulsion, this is what is happening. In rocket propulsion also, we use the conservation of momentum. You have studied the rocket propulsion. It's a topic in laws of motion only. When we studied that rocket propulsion, we do the derivation and all this thing. We do that in rocket propulsion also. In rocket, and that is a case of variable mass system. Variable mass system means mass is not constant, because rocket is considered to be an empty shell in which rocket is considered to be an empty shell in which fuel is there, and once the rocket is going up, moving up, the fuel comes to an end and its mass decreases. Okay, so shall we move now? So here I am considering that the mass is remaining the constant, the mass is not changing. If the mass is not changing, then what we can do is, let's say if the mass is not changing, then m1 v1, m2 v2, m3 v3 plus up to mn vn. So this is what is happening. Okay, and this is if I consider in one dimensional motion only. If I consider this as in three dimensional motion, then what will happen? I have to do the conservation of momentum in along x, y and z axis. Okay, that how we can write in? Let's write this: conservation of momentum along x, y and z axis. So in that case I will have to do the conservation of momentum along x, y and z axis. Okay, how we will be doing that? We will be doing in this way: m1 u1, I will be writing u1x. Okay, that is the initial velocity along x axis. m2 u2 x, m3 u3 velocity along x axis. Mass is not going to change, mass will remain the same, only the velocity.
So this example which you gave is around x, y and z axis, three-dimensional motion.
Yes, suppose the objects are interacting with each other, or they are colliding with each other, or whatever the situation is happening. In that situation, suppose I took the example of over here, I am considering only one dimensional motion over here, no two dimensional motion, or the objects are moving in the straight this line only, na? So conserving the momentum along this axis, one axis only, there is no other axis, isn't it? So that's why we can write like this: if we have to do the conservation of momentum along one axis only, then we will writing this equation, conservation of moment. And if it is moving along the positive x-axis, it will be plus v, and if it is moving in the negative x-axis, then it will be minus. Suppose it is moving in positive x-axis, so it will be plus v. The other object is moving in the negative x-axis, it will be minus v. Okay, likewise. And if we are having the same thing in 3 dimension, suppose one particle moving along this direction, another like, so what will happen in that case? What will do? Suppose if a particle is moving along, if a particle is like this and it is moving along this, we will make 3 components: one momentum along x-axis, momentum along y-axis and momentum along z-axis, and we will write the conservation of momentum along x-axis, along y-axis and along z-axis separately, and then we will solve them separately. This is how it is. Okay, so shall I write this equation? And m1 u1x, m2 u2x, m3 u3x, likewise mn unx, it will be equal to m1 v1x, m2 v2x, m3 v3x plus up to dot dot mn vnx. This is how it is. Similarly, we can write the same thing for y-axis, and we'll be solving them separately. We'll be solving x-axis equation separately, we'll be solving y-axis equation separately, and we'll be solving z-axis equation separately, not the same time. So for y-axis, what I can write? m1 u1y, m2 u2 along y-axis, m3 u3 along y-axis, and plus sign over here, then dot 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 again plus mn un y along y-axis, same over here, m1 v1 along y-axis plus m2 v2 along y-axis, the y small over here, m3 v3 along y-axis plus dot 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 again plus, and mn vn along y-axis. So this is what we are writing. Same thing we can write for z-axis. Okay, and we'll be solving that. m1 u1 z, m2 u2 z plus m3 u3 z plus up to mn un z is equal to m1 v1 y, m2 v2 y plus m3 v3 y plus up to dot dot mn vn y. Actually, this is z actually, not y, z. This is z and this is z. Okay. So this way we can solve these equations. So I think this is the very basic concept, and we do the conservation of this momentum in this collision also. We study the concept of collision and work, power and energy. There we do all these things in more detail. There we do what we do there. We do different types of collision also there. So I think that is not the part of conservation of momentum. That we'll do later on when we'll be studying that conservation of in work, power, energy, collision topic. I think this much is sufficient. Theory portion I think is sufficient for the conservation of momentum. We can go for the numericals if you want.
Yes, sir, numericals.
Okay. Shall I rub this part and shall we start with the numericals part? And along with this we can have third law of motion. That is the statement is there. Now let's come to the numerical portion. Let's come to the numerical portion of this. See, we can have numericals from conservation of momentum and conservation of energy. Okay.
Yes, sir.
Okay. So now let's try to conservation of momentum. Okay, let's write a question. Shall we love this? Everything?
Yes, sir.
We are starting from the easy question, then we'll move to some difficult questions. See, the question says a 30-gram bullet. The question says,
Any question, sir?
no, it's not an NCERT question, it's different question. A 30-gram bullet, a 30-gram bullet leaves a rifle with a velocity of 300 meter per second. Okay, what they are saying, and the rifle recoils with a velocity, and the
The recoil means the inertial velocity of the gun, right?
no final rifle recoils with a velocity of 0.60 meter. Now what they are meter per second. Okay, what they are asking now, find the mass of the rifle. Can you find the mass of the rifle? It's a very easy question. Now we'll move to some difficult question. Find the mass of the rifle. Can you find the mass of the rifle? Now how will you solve this question?
So you write down the given, that you substitute in the formula M1 U1 plus M2
Yes.
plus M1 plus M2 U2 V2.
Yes. If I consider there is no external force, nothing is there. I consider mass of bullet, m as the mass of the bullet, which is 30 gram, and 30 gram I have to divide it by I have to convert into kilogram actually. So 30 divided by 1000, what is the mass I am getting? It is 0.3 kg, 0.03 kg, isn't it?
Yes, sir.
Or I can write 3 into 10 to the power minus 2. Can I write like this?
Yes, sir.
3 into 10 to the power minus 2 kg. This is the mass of the bullet. Okay, that we can see. Now the next thing, what is the mass of the rifle? I am assuming the mass of the rifle as capital M. We don't know it, we have to find it. Next thing that we have given, a 30 gram bullet leaves with a velocity. Now what is the velocity V1? V1 is the velocity of bullet actually. Final velocity of bullet, not the initial velocity of bullet. Are you getting this thing? Initial,
What is final, so isn't it initial?
no. Initial velocity of bullet is, let's say, 0. Initial velocity of gun is 0. This is the initial. Let's take this U1 and U2. This is the initial velocity of bullet and gun respectively. Initial velocity of bullet and gun U1 and U2. Okay, so they are 0, both are 0. U1 is equal to U2, U1 is equal to 0 because
For all the cases of the gun related type questions, or initial velocity is 0.
no, if the situation may vary, but if the gun is not fired till, then it is 0. Okay, there may be some different situation also. We need to consider that. But in general, if we talk about, it's 0. There may be some special case, or they may give something else situation. Then it may vary. Otherwise, in general, it is not so. It is 0 only. So the initial velocity of the bullet and the gun is 0. And the final velocity, they have given the final velocity of bullet gun also. What is the final velocity of gun? It is 0.60 meter per second, isn't it?
Yes, sir.
So they have given. Now according to the situation, there is no external force. Whatever the force is there, it is between the gun and the bullet. Gun is applying a force on the bullet. Bullet in return applying a force on the gun. According to Newton's third law, it's no problem. And these are internal forces. And internal forces will not make any change in the momentum, because the momentum can change only because of the external force. So external force is 0. I can write it like this. If external is 0, I am writing all these things to explain you. You can straight away do the question. That means initial momentum is equal to final momentum.
Yes, sir.
You can straight away put the value and find the answer. I am just doing all these things to make you things understand. Otherwise, so this means initial momentum is equal to final momentum that we are getting. And we know the initial momentum is 0. No need to write these values. Just put 0 over here and find the answer. I am writing it just because M1 U1 plus
We have to
M2
take
U2.
sign convention, right?
Yes, we have to take sign convention also. And here I am considering, let's say if I am considering this direction, let's say this is my gun and the bullet is coming like this. If I consider this direction as negative, then automatically opposite direction will become positive.
Positive.
Okay, but I am considering this direction as positive. So let's see what is the answer of this. So initial momentum is equal to final momentum. Final momentum is what? Again M1 V1, and this is M. This is how it is. Okay, M V1 plus M V2. We have to find the value of M, and you can see from here this equation is 0. U1 U2 0. Initially gun and bullet both were at rest, nothing was moving, so initial momentum is 0. Are you getting this thing? So just simply put 0. No need to do all these things. Just write down these values and then write initial momentum is equal to final momentum. This becomes 0. And what you can see from here, mv1 plus mv2. And what we have to find? We have to find the value of m. So m is coming out to be, you can straight away put like this, minus m v1 upon v2. So shall we put the value and find the answer? What is the value of m? M is 3 into 10 to the power minus 2 with a negative sign. V1 is how much? It is 300. And V2 is how much? It is 0.60. Okay. So once I remove this decimal, what I am getting over here is 100. Isn't it? This 100 and this will get cancel with each other. Is it okay? Now what we are left with, this 0 and this 0 will get cancelled with each other. 6 and we are having 30. It is how much? 6 5s are 30. Yes, what about? Yes, sign we can see over here. Once this value go to this side, it will be negative and it will be like this. Okay. And let's find out the mass. Mass what they are getting? We are getting 50 kg. Now we can see over here this mass is coming out to be negative. It is minus 15 kg. It is coming out to be, you can see over here, because once this value go to this side, a negative sign over here, and you can see negative of this, and this V2 will go over here. Okay, and the mass will not come negative. Let's see how. Just because I have not put the value. Once you put the value of V2, V2 will be what? It will be minus this. Are you getting this thing? It will be minus of this, isn't it?
Yes, sir.
Because the gun will move in this direction. So we have to put the value of this. It will be minus. So once you put the value of this, yes?
Why you multiply with 100?
Just because I have removed the decimal over here, 0.60. I have removed the decimal, so multiplying 100 with 100. It's okay? So, and I have to put a negative sign over here because the velocity will be in this direction. So negative and negative will get cancelled, they will become positive, and the mass of the rifle will come out to be 15 kg. It's okay? This is a very simple question. That's a 9th standard question actually. Now we'll come to some difficult question. Okay, you have done this. Shall we move to the next question now? Okay, now we are taking the next question. See, a 40 kg shell is flying at a speed of 72 if it explodes into 2 pieces. Out of the 2 pieces, mass 15 kg stops. Calculate the. Now come to the next question. I am taking another question. Shall I rub this part? Rub this question? I am rubbing this, and now we are taking another question. The concept will be same, everything will be same. The question will be different. Now the question says a 40 kg shell flying. The question is like this: a 40 kg shell flying with a speed of 72 kilometers per hour. Okay, it explodes it explodes into two pieces. It explodes into two pieces. Now what they are saying, one of the two piece of mass 15 kg, one of the two piece of mass 15 kg stops. So this mass of 15 kg stops actually. So what they are saying, calculate the speed of the other. Calculate the speed of the other. So this is they are asking. How can you solve this? See, since they said this system is exploding, there is no other forces. The only force that is coming is from its internal force, and that internal force is actually, see, in this moment in explosion, the momentum is conserved. And what about its energy? Its kinetic energy? Its kinetic energy is not conserved. Okay. So now let's since there is no force and no external force, now let's take its initial mass as capital M. Take it as 40 kg, it is given. Now what is happening? It explodes into two pieces. One of the piece of mass, calculate the speed of the other. So let's say the first piece, it is of mass, how much? It is of mass 15 kg. So what will be the mass of the other object? 15. If you
40 minus 15.
it is 25 kg, isn't it?
Yes, sir.
So the first mass is of 15 kg, the other mass is of 25 kg. Now what they have said, the first mass, let's say take its velocity as, they are saying it has stopped. They are saying that it has stopped. Now calculate the velocity of the second mass. We have to calculate the velocity of V2. This is what we have to do. Since there is no external force acting on the system, that means initial momentum should be equal to its final momentum. That means put the values. Initially, what was the initially? It was a one body system. Now consider one more thing here. Sometime we have just before we have discussed that a body is of n number of system or two body system or something like that. But now you can see one more thing over here. It may happen that here it may be of one body system, and here it is becoming a two body system, or maybe three body system, because it is breaking into that number of particles. Are you getting this thing? Here you may have only one body system, and here it may break into four parts. So you have to add on the mass and momentum of all the four parts. Similarly, here you may have the four body system, and here they may join and stick together and become a one body system. So these type of things you need to understand. What will happen here? It is having the momentum. Let's say this is m and it is moving with some velocity. What is the initial velocity of this object? It is moving with some initial velocity. How it is? 72 km per hour. It's okay?
That's the velocity of the 40 kg shell.
Yes. Kilometer per hour. So let's say we are having this 40 kg shell. It is moving in some direction. We don't know in which direction it is moving. Let's say it's a 4, and we are considering it to be its direction to be as positive. Let's say. Okay, whatever direction it is moving, we are considering its direction to be positive. So let's write this equation like this. This is m1 and into u. u is this initial velocity, and here what will happen, m1 into v1, but it will become 0. Why it will become 0? Because this velocity is 0. So now m2 into v2. What we have to find? Calculate the velocity of this. We have to find v2. So now just put the value. This equation becomes 0. M is how much? 40 kg.
So what about M1, U1 and M2, U2? What about that?
What about here?
So why in this case you took only final momentum for those two pieces, but for initial momentum you took? Yes, sir.
I'm not taking this thing. I'm not taking this thing. This is what I told you just before. We need to check that here I am having a one body system or what, or a two body system or three body system, whatever it is. Here I may have one body system, but here I may have three body system. Here I may have four body system. Here I may have only one body system. It may appear that this equation come to this side, this equation may come to this side. You need to see the situation. You need to see the situation. Initially, this is the situation. Initially, we are having only one object, having mass m, moving with velocity, let's say u, and this direction is I am considering as positive. This is my initial condition. Now, sometime later on, what is happening? It is breaking into two objects like this, and this is m1, this is m2. Now, what they are saying, the m1 is of 15 kg. This comes to rest. It is not no more. It is not moving. They are asking with what velocity this m2 is going to move now. This is the situation. This is the momentum before. This is the initial momentum, you can say. This is the final momentum. Are you getting this thing? And I am considering this as my system. Here this is my system, and here this is my system, because it is coming out, something is coming out from here only. And if some, let's say 4 particles, it becomes into 4 particles, 3 particles. In that situation also, those 4 particles will be my system. I will be writing them one by one over here. But here only one particle system, so I am writing this only. No writing this. We will be writing this when we are having 2 particle system over here. Are you getting this thing?
Yes, sir.
So now coming to the situation. And I am considering this as my positive direction, so I will be writing u as positive. Just put the values. And moreover, I am not converting the units over here. You can see it is written kilometer per hour. We are taking kilometer per hour. The answer will be in kilometer per hour. Otherwise, because there are no other units in the world, na? There are no other, because I am not doing any other calculation. There are no other units in the world. If some unit in some other unit, or one unit in this system, then there is a requirement to convert the unit into one particular system. Here I can put the values because the answer will not come wrong, because I am having only one system of unit, and that's it. No other units are there. If some unit is given in CGS system, another value is given in some other unit, and another value some other unit, there we need to convert the unit. Otherwise we will be doing calculation mistake. But here I can do it because only one system is there, nothing else is there. So it's 40 kg and it is moving with 72 km per hour. Putting the value over here. Now here V1 is how much? V1 is 0. So this 15 multiplied with 0, it is becoming 0. Nothing will happen to this. And you can moreover see this V2, after this it is breaking into 2 parts. This V2 will again move in this direction only, whatever the direction was of initial mass. So what is the value of M2? M2 is 25 kg and we need to find this value V2. So rest everything is done. It's 40 into 72 is equal to divided by 25.
2800.
Yes. So now you can divide it with 5. 5 5s are 5 8. So it becomes how much? 72 into 8 divided by 5. So finally how much you are getting? Let's solve. 72 into 8 divided by 5. Okay. Divided by 5. Yes. So how much we are getting? Yes. Yes. 72 into 8. Yes, 115.2 kilometer per hour. If you want to convert into meter per second, that also you can do. 115.2 kilometer per hour. Okay, this is what you can do. Or if you want to do the calculation in meter per second, let's say, this initial velocity can be converted into meter per second. How we can convert into meter per second? 5 by 18. How much it will become? 8 for the, it becomes 20 meter per second.
Yes, sir.
So it becomes 20 meter per second. So if I do the calculation by this, 20 meter per second, that also you can do. Let's do that also if you want. Let's say it will be how much? 40 into 20 meter per second, and it will be 25 V2 like this.
Yes, sir.
So V2 will come out to be 40 into 20 divided by 25. So if I divide 25 by 5, 5 and 8 over here, and 5, it becomes 4. So you can calculate it in meter per second. 8 for the 32 meter per second. Either you can do the calculation in this form, or you can do in this form. But better is you do in this form. Okay.
Yes, sir.
We can do it in this form because there is no other conversion of units. But better is you do in this form. Shall we move to the next question? You have already noted it down.
Yes, sir. 1 minute, sir. So, sir, one doubt. So how do we consider in this case you said the initial momentum for one body system and for the final momentum two bodies. So how do we consider the leads we have to take for one body?
No, that you have to see the question, na? You see the question that an object is moving. That means one body system. They will mention in the question the two particles are colliding. One body is going, gun and fired from the bullet. Just like that, you have to take this information from the question itself. And how you will understand this? You just need to practice few questions. When you will practice few questions, you will understand that how to take these things. Okay. Initially, without practicing question, without going through problems, you will not understand like this. You will have to do certain number of questions, and then you will get this information from the question itself only. And with some practice, you will understand how to take these values. Okay, shall we move to the next question now?
Yes, sir.
Okay, I'm moving to the next question. The next question says, a body of mass 1 kg initially at rest explodes and breaks into 3 fragments of mass. The two pieces fly off to each other with the speed of. What is the velocity of the heavier fragment? Now let's take this question. In this question, we will be doing the objects are moving in angles. Okay. So let's take this question. Next class, when you want to take, then?
Sir, can we take tomorrow, sir?
Okay, at what time?
Same time?
Okay, 7 p.m. IST. Yes, we can have.
Okay, sir.
So now let's take the another question. In this question, what they are saying, a body of mass 1 kg. A body of mass 1 kg. Okay, initially at rest